Welcome to The Explainer. Today, we're doing something pretty cool. We're going to peer into the invisible world, exploring the incredible technology that lets us see right inside solid objects. Everything from the human body to super high-tech materials. It's one of those questions that sounds like it's straight out of science fiction, right? But it's a reality we rely on, pretty much every single day. The answer lies in a technology that has completely changed the game in both medicine and engineering. All right, let's get into it. So take a look at this. At first glance, you might be thinking, okay, that's a medical scan, right? Some kind of human tissue? Well, it's not. What you're actually looking at is an incredibly detailed inside-out view of a piece of advanced composite material. The kind of stuff they use in aerospace or high-performance cars. And this really hints at the true massive power of this technology. So how in the world do they do that? I mean, how is this even possible? To really get it, we need to break down the fundamental idea behind it all. The tech behind the magic is called computed tomography, or, as you've probably heard it, a CT scan. Put simply, it's a really, really smart way of using X-rays. Instead of just taking one flat picture, it creates thousands of digital slices of an object, which a computer then magically stitches together to build a complete 3D model. And this is a great breakdown of how it works in 5 key steps. First up, an X-ray source shoots a beam right through the object. Step 2, on the other side, a detector measures how much of that beam actually made it through. See, denser stuff blocks more X-rays. Then, step 3, the whole setup, the source and the detector, rotates around the object. And as it spins, it collects hundreds, sometimes thousands of these 2D pictures, or projections, from every possible angle. That's step 4. And then finally, the magic, step 5. A powerful computer takes all those flat images and reconstructs them into one incredibly detailed 3D image. But this incredible technology didn't just pop up out of nowhere. The history of how it evolved from being ridiculously slow to lightning fast, well, it's just amazing. And this timeline really tells the story. I mean, look at the sheer speed of progress. The very first scanner back in 1971 took over 5 minutes for one single slice. Can you imagine? Then they introduced fan-shaped beams, which cut that time down a ton. The third generation, with its rotating system, basically set the standard we still use today. And now we have these unbelievable systems with 2 X-ray sources and advanced flat panel detectors that make scans faster and more detailed than ever before. This evolution kind of led to a big decision point in scanner design. Do you use a fan beam or do you use a cone beam? And this choice, it involves a really important trade-off, especially for doctors and their patients. The difference is really all about the geometry, the shape of the X-ray beam. Fan beam CT is methodical. It scans one thin slice at a time, building the picture layer by layer, like building a loaf of bread one slice at a time. Cone beam CT, on the other hand, blasts a wide cone-shaped beam to grab a whole volume in one single spin. It's like capturing the whole loaf at once. It's way faster, but that speed comes with a price. And this table lays it all out, crystal clear. Yeah, cone beam gives you superior spatial resolution. That just means sharper, higher detail. But, and this is a big but, it also comes with more image noise, more artifacts, which are kind of like weird visual glitches in the scan, and a higher radiation dose for the patient. For image quality and patient safety, fan beam is the clear winner. So what's the big takeaway here? It's this. For the absolute highest quality images, the ones that are clearer, more accurate, and show amazing detail in soft tissues, fan beam CT is just the better technology. That's why for a really critical diagnosis, your doctor is almost always going to want a fan beam scan, even if it takes a little bit longer. But hey, the innovation doesn't stop with the X-ray beam, not even close. The most exciting revolution in CT right now, the real game changer, is happening on the other side of the equation, inside the detector itself. Just look at the difference here. On the left, that's the old way. An X-ray hits a crystal, the crystal flashes with light, and then a sensor measures that light. It's an indirect, 2-step process that creates static or noise in the image. But on the right, that's the future. It's called photon counting. It completely skips the middleman. Each individual particle of X-ray energy, every single photon, is converted directly into a clean electrical signal. The secret is right there in the name. It literally counts the individual photons. Instead of just sensing a fuzzy burst of energy, it registers each and every photon and, this is the crucial part, it measures its specific energy level. It's like the difference between hearing a muffled crowd roar and being able to pick out every single voice. And the real world impact of this is just, wow, it's staggering. You get ultra high resolution, you completely eliminate electronic noise, and because it's so incredibly efficient, you can massively lower the radiation dose, which is huge for patient safety. It can even tell different materials apart inside the body during the same scan. That's a massive leap forward. Okay, so we've seen how CT has completely transformed medicine. But what's really amazing is that this technology's impact is just as big, maybe even bigger, outside the hospital, in the world of engineering and manufacturing. Think of industrial CT as giving engineers X-ray vision for the modern factory. It's one of the most powerful tools out there for quality control. It lets them find hidden flaws, tiny cracks, air bubbles, parts that aren't put together right, all without ever having to slice the part open. For instance, check out this light white car seat. After you put it through a bunch of intense stress tests, how can you be absolutely sure it's still safe? You scan it. The CT slice reveals hidden cracks and spots where layers of material have pulled apart, information that is absolutely critical for safety. This is the kind of thing that prevents a recall, or worse, a serious accident. And it's not just about quality control, it's a tool for pure invention. Here, scientists are looking deep inside a new composite material. By seeing this complex internal structure, they can figure out exactly how it works and where it gets its strength. This is literally how we invent the next generation of materials for everything from airplanes to our smartphones. Okay, now this is where it gets mind-blowing. This special rig lets engineers scan a part while it's actively being stressed, pulled, crushed, or twisted. It's called in situ testing. You're not just seeing the damage after the fact, you are watching a failure happen in real time at a microscopic level. It completely changes how we design things. And this quote from the research just hits the nail on the head. The unique power of CT is that it can create a perfect digital blueprint, a CAD model of a part's insides and outsides. Engineers can then take that digital twin and use it in computer simulations to predict and prevent failures before a single physical part is even made. It's a total game changer. So when you think about it, from diagnosing diseases earlier and with less radiation, to building safer cars and pioneering materials we haven't even dreamed of yet, the power to see the invisible is fundamentally changing our world. The only question left is, with this vision getting sharper and clearer every day, what will we discover next?